Welcome back to World Talks, coming to you live from Warsaw. I'm Salia Strzemska. More than 50 years after the Apollo program, humanity is venturing back into deep space. With NASA's Artemis II mission, a new chapter in lunar exploration has begun, bringing fresh scientific ambition and the promise of a long-term human presence beyond Earth. To discuss this, I am joined by Artur Chmielewski, Program Manager at NASA's Jet Propulsion Laboratory. Good evening and welcome to World Talks, sir.
Thank you for inviting me.
So at the moment, the Artemis II crew are closer to the moon than they are to Earth, further than any humans have traveled since the Apollo program. So why has there been such a long gap over 50 years?
Yes, at the time when we finished Apollo, a couple of things happened. First of all, the United States felt they won the race, and it was a race to the moon, a race to show humanity that the United States is the most advanced country over Russia, right? So we felt, okay, won the race at that time. We reached the finish line, so there's really no reason to convince anybody. So there was this lower impetus to continue. Also, at that time, we didn't have as good understanding of the moon. We didn't have understanding of the resources on the moon. We did not know that there's water on the moon. Finding water on the moon was a major, major thing that changed our perspective on our satellite.
So a major milestone of the mission will be the lunar flyby taking place tomorrow. That is on Monday, day 6 of the mission. So this will include views of the far side of the moon. What are scientists most excited to observe during that phase?
Well, this is a part of the moon that has never been seen with human eyes. And so this is always exciting to see something we haven't seen. It's been imaged by spacecraft, but never seen by man. So that's a first. Whenever you have a first, it's interesting. Also, astronauts are flying far away. The farthest point for humans to be away from Earth. So that's exciting too. And it's also exciting from the scientific point of view because we're checking the radiation, the behavior of astronauts, their reaction to stress, sleep patterns. We can measure these things so much easier than we did 50 years ago because they can wear a little watch that will tell them a lot about how they sleep, what was the rapid eye movement during the sleep, how stressed they are, what was the heartbeat, without huge instrumentation that would be required during the Apollo times. So these are different times, different spacecraft, different idea. We're going to the moon to stay. So that also changes the perspective of this whole mission.
But there will also be a temporary loss of communication during parts of this flyby. So how are the astronauts preparing for this?
Yeah, so that's, I think we're going to lose communication for about 41 minutes. I work at the Jet Propulsion Lab here in Pasadena, California. We're mainly developing robotic systems for flight, but we also are used to this losing communications. Whenever we land on Mars, we lose all the communication at the critical time with our spacecraft, landing on Mars for 7 minutes. And we call it 7 minutes of terror because one little resistor burning and one little thing going wrong, we cannot communicate with the spacecraft at that time. So we're terrified that this expensive mission that took 7 years to build, that something will go wrong. This is a little different with astronauts. They will cruise through that time. But of course, operators at Houston are very uncomfortable when they cannot see continuously the astronauts, see how they are doing. And there are, of course, continuous dangers in space.
Mm-hmm. So now a little bit more on a technical side. The Orion spacecraft is essentially a small camper van-sized environment, right, for these 4 astronauts over several days. And we've already heard about some technical issues, including problems with the toilet. So how typical are these kinds of challenges and how do crews adapt in real time? Are they trained for this?
Yeah, so this is why uh, they have to have understanding of every system. They have to understand where the power plugs, what is every cable, what is every line, how the toilet works, right? They do get live help. They call the customer support in Houston and say, okay, we have this fan that allows us to urinate, right? And it stopped. It doesn't pull the urine in the right way. What are we going to do? So they tell you how to take it apart and maybe repair it. I'm actually amazed if you come close to the rocket or the spacecraft and you see the snake nest of cables, connectors, pipes, valves. You're actually amazed that everything is working as well as it does. Funny thing is that the toilet broke, but we can. They almost fixed the toilet, so that's good. So and you want to have these little glitches because then that's how you learn how to fix things and what tools you need to have on board. So you want little glitches. You don't want major problems, but little glitches are very welcome.
Of course. Now, Artemis II is the first crewed mission in the Artemis program, but the first landing of the program is now, I believe, planned for 2028. While the Chinese are aiming for 2030. So there's clearly a geopolitical dimension to this effort. Why is it so important who gets there first? Or is it perhaps more important who can go more frequently and sustainably, not necessarily the same country, right?
Yeah, so this is scientists and engineers, they don't worry as much about being first. The politicians do. There's an certain ego attached to it. But we at NASA, we feel that we're doing this away from politics. We're doing this to do good things for our planet, right? So we go to the moon not because we want to be first, not because we want to arrive a day earlier than the Chinese, although there's a factor there, because for some reason, the way we operate, like we know who won the World Cup, but we don't remember who came in second, who won the gold medal, but not the silver. So this is how funny human mind works. But we're going there to do good things for Earth. The whole science exploration is, for example, we study Mars and Venus. Why do we do this? I mean, who cares about these planets? They are so far away. Well, one is super hot, the other one is super cold. Water evaporated from it, and from the other one, all the water froze underground. Well, we don't want this to happen to us, so we better understand it. Same with the moon. The moon offers us an answer eventually to the hardest question and hardest problem on our planet, which is generating clean electricity. There's plenty of helium-3 on the moon, so we'll be studying how to extract it, how to bring it back on Earth. Of course, we need fusion for this, but that's a huge promise for humanity. So we're going to the moon as engineers and scientists to stay, and we welcome international cooperation in that purpose.
The goal, of course, is very important, but I wanted to talk about money for a moment, because at the height of Apollo, NASA's budget, adjusted for inflation, was around $40 billion annually. Now, by comparison, NASA's total budget today, from what I gathered, of course, is significantly lower. Last year was around 20-some billion. And now there are also further cuts being proposed for 2027 of around 23%. So how will Artemis and future missions be supported?
Yeah, it's an excellent question. It's a tricky one. So the burden was put on engineers to figure out how to get to the moon cheaper. So the idea during the Apollo times was we were building these humongous rockets, Saturn V, and they were just disposable. You use them once, gone. So now the idea is, if we want to go to the moon and stay and send supplies there, cargo ships, being continuous and bring stuff back from the moon, operate the space station, you have to have these frequent flights. and you cannot have that huge budget continuously. So engineers are trying to figure out how to do it in a less expensive manner. And one way to do it is to have reusable spacecraft, like the Starship. So, for example, now the idea is that first we send a lunar module up into vicinity of the moon, and then we have another spacecraft, Starships, for example, go up to the lower Earth orbit, and then we have several of these ships going and refueling until one is fully fueled and then flies back and flies to the moon and flies back. So, and that offers also humongous cargo capacity. I think that was the lunar module during the Apollo had few tons that were available. Now we're talking about 100 tons. So we're not taking a little one bedroom to the moon, but we're taking a 3-bedroom to 2-bath house to the moon. So that's a different thinking, but reusability, we're only paying for the fuel as opposed to paying for the whole spacecraft, for the whole rocket. That's the idea on doing this on a much lower budget.
Right, and commercial partners like SpaceX and Blue Origin that NASA cooperates with, I mean, how reliable are these guys? And how viable are these partnerships?
Well, we say space is hard. Space is hard. And it's good that it's hard because we force our engineers to do these incredible things. Then later they make a lot of inventions, they start little companies, they have products. Of course, like for example, this little item, we wouldn't have it if it weren't for space. There are 6 space technologies in it that Apple put together, right? So we do hard things and then we turn it into inventions that fuel our economy. Fine, but these are extremely difficult things, and we also want to explore moon in such a way that it's profitable to the industry. So the government doesn't have to pay for it all the time. The government pays for to remove the risk from the mission for this first trip, and then the industry would take over, and industry would have benefits of extraction of resources from the moon, of helium-3, of water, building rockets there, building industry. So that's the long-term idea behind it.
Mm-hmm. However, there are rumors of SpaceX potentially going public. If this happens, could that affect its operations or its relationship with NASA?
That is a question for economists. Of course, we wish all of these companies to grow, to be strong. We help them out with substantial injection of money, SpaceX, Blue Origin. We want them to succeed. How are they going to conduct their business? Hopefully, they are smart about it. So they stay in business, they are profitable, they are strong, and then they can help NASA explore the moon and planets and other places, protect our planet from asteroids coming in, all of these things. So it's not all on NASA or European Space Agency, ESA, or other agencies, but it's on private industry as well.
Artur, and before we go, looking beyond the moon, the Mars Perseverance rover is currently searching for signs of microbial life on Mars. When can we expect meaningful results from that mission, and is Mars truly the next destination for human exploration?
Yeah, it's definitely the next destination. We're hoping that the moon base will be thriving, the industry will be operating it, so that will free up money for NASA. And the next destination is Mars. We're thinking about using nuclear reactors to travel to Mars to speed up this trip, because one of the things that are very interesting about this moonshot is it takes 10 days, right? And we are examining every hour the health of the astronauts. There's this exciting experiment called Avatar on board, which tests how human cells, how human DNA responds to microgravity, stress, radiation. But that's 10 days. If you want to get to Mars, that's 7 months. That's a long time. A lot can happen. And you better get along also. Not be so stressed out during the trip. You better have 3 very close friends on board because the capsule is small. So you have to be happy and behave and be friendly and be healthy. How do you sustain your health during 7 months under radiation and stress, and you're in a tiny little container moving in vacuum between 2 planets? That's, to me, it's really scary.
It is very surreal indeed. Artur Chmielewski, thank you so very much for joining us tonight, and of course, fingers crossed for the safe return of Artemis II.
Thank you so much.
And thank you for watching World Talks. Please stay tuned for more here on TV2 World.